Hello, we are going to solve this example of a second degree inequality. This is a second degree polynomial. So if we draw this polynomial in coordinate axis, this would be a parabola, right? So first thing we are going to do is we are going to calculate roots of this polynomial. To calculate the roots, we are going to use the second degree equation formula, because remember that a root is a number that if you place it instead of the variable, you will obtain 0 as a result. So that's why to calculate the roots, we just have to solve this second degree equation. And it would be 5 plus or minus, because it's negative b, square root of b squared, which is 25, minus 4ac, that is 24, all over 2a. This equals to 5, this is 1, square root of 1 equals 1, so 5 plus 1, 6 over 2, 3. 5 minus 1, 4 over 2, 2. Here we have the roots. If we want to graph this polynomial, this function here, remember this is the x-axis and this is y-axis. When we input 3 and 2, 1, 2, and 3. When we input 2 and 3, we said that the result is 0. That's why we solved this equation. So this point and this point will belong to my parabola. Then we know since this coefficient is positive, the second degree coefficient is positive, we know that the parabola will be like this. So let's say my parabola is something like this. Since I'm looking for values where my parabola is positive, when I input x, so that my parabola has positive results. This will happen when I place values of x here, because the result will be positive. It is upwards in the y-axis. If I place these values of x, my result will be negative because my y will be downwards. Right, so now just looking at the graph, I know that x, my solution, will belong. My solution x will belong from negative infinity till 2, excluded because it cannot be equal to 0, and plus the interval from 3 till infinity. Let's say I don't want to graph the parabola. There's another way. I can write this, I can factorize this polynomial once I know the roots because of the factors theorem. And I can write that this is x minus 3 times x minus 2. And this must be greater than 0. This is a product. This product equals this polynomial. So this is another way to write the same inequality. So I need to study the signs of the factors to know the sign of the result, that is the product of both. So I'm going to write this factor, I'm going to write the other, and I'm going to write the product. And now this represents the number line. I'm going to place the roots here, which are 2 and 3. These values will make one of the factors equal to 0. Now, remember that negative infinity will be that way and positive infinity will be this to the right. So if I have a value that is less than 2 here and I place it here, this factor will be negative. If I have a value between 2 and 3, this factor will be negative as well. And for values greater than 3, this will be positive. In this case, for values that are less than 2, this is negative. If my values are between 2 and 3, this is positive. And for values that are greater than 3, this is positive as well. Then the product will be negative times a negative, a positive, negative times a positive, negative, and positive times a positive, positive. This is what we predicted in our graph. Look, between 2 and 3, downwards, so negative values, and here positive and positive. So my solution is in this interval plus this interval. We can write it as we did before. I hope you understood. See you soon. Bye.